Welcome back. This is going to be part B of mailbag number 6. Actually, that was posted yesterday on Thursday. Today is Friday, and yesterday I happened to have gotten another box in. So I'm going to start, obviously, today, start with the reviews, and then as I get the rest of the pieces in, I'll just keep adding to this video. So who knows when this one will be posted. But I thought it was kind of funny the day I was posting this first part, I managed to actually get pieces in and start possibly filming the second part. But anyway, this particular thing is actually a set of buck boost converters. Now, a buck converter will take voltages and step them down to a specific voltage. A boost converter takes a specific voltage and boosts it up. A buck boost converter does exactly what it sounds like. It does both. And there's an order, I believe it bucks it first, then boosts it, or I'm not really sure, but the point is you get a fixed voltage no matter if the input voltage goes high or low. And that's important for situations where you're using batteries, let's say, and the batteries go below a certain point and then no longer provide juice. And one of the instances I could think of is when you have a device like a battery pack like that, for example, and you want to get a fixed 5 volts out. Well, by default that's 12 volts, so you need something to step down to 5. But what happens when the voltage gets to the 5 volt point, because these are going to obviously get down to that point? Well, you have a circuit now that can actually boost the voltage back up to 5 volts. And I know there's all kinds of things about efficiency and whatnot, but that's kind of cool that you can actually do that and get a stable voltage. So I figured for reasons like that, I built a battery pack with one in it. And then I also built one in this train engine that would keep an LED at a constant voltage no matter how fast or slow the engine was going. The problem is they only have a fixed voltage, I should say a fixed amperage of 2 amps total. And I wanted something that maybe put out a little bit more power, so I came across these on eBay, and for the set of 2 it cost me $4.99 with free shipping from China, which I thought was pretty cheap. And the other ones were about half that for a set of 2, so you can get an idea. You're getting twice the power for twice the price. But these, you can see they're built for definitely for higher output, because they have much larger inductors, which are these 2 guys over here. Same chipset, but the chipset is also sitting on a giant, looks like a giant ground plane here with a bunch of holes in it to help dissipate heat. Those holes are vias that allow more surface area, I guess you could say, for the heat to couple the 2 surfaces between front and back, so any heat would just transfer through those holes to the other side here. I guess, you know, that chip's going to get quite hot with all the current going through it, obviously. And I might actually get little heat sinks and just put them on top, or put this in an area where it's going to be cooled. I'll put the specs and the link to see this down below, but I can really quickly tell you some of them. Now, this has an input range of 5 to 32 volts and an output range of 1.25 to 45 volts. And it says a maximum switching current of 4 amps. And anything else you need to know, you'll just check out the link below. But another way you can call these, this is also known as a SEPIC, S-E-P-I-C, a SEPIC converter. So you can always Google that term if you want to learn more about how these work. But it's very similar to a regular buck or boost converter configuration. It looks more like a buck converter. If you look online, you'll see them. They look very similar, with a inductor, a capacitor, and a little chipset, and maybe some ancillary components here. Maybe like this diode over here. But this one, you'll notice most of the ones that are buck boost converters like this has the second inductor on it, and that's obviously for one's going to be the, you know, for the upper, and one's for the lower limits. And then to adjust it, you would just, you know, use this adjustment right here, and this is one of those multi-turn trim pots you can just constantly turn, so you have a much easier range to adjust this with. And then you have your your clamps over here, and 2 standoffs. That's basically it. I mean, there's really not much to them. but they were nice little boards and cheap modules for the money. So I have a couple ideas of what I'm going to do with this. For certain, I'm going to try maybe redoing this, obviously if I can get something with a higher amperage. The thing is certain devices like a tablet, for example, the charger puts out like 2.1 or 2.4 amps, and you know, that's the difference between it being a slow charge and a normal charge for those particular units. Cell phones, you know, like my old cell phone, I can charge it on a 700 milliamp charger. I don't need a lot of juice, but if I do plug it into something with a little more current output, it tends to actually get a little bit of a better charge, because you know, when those things kick in and you get some kind of a surge or things like that. Anyway, topic for another story, obviously, but you know, this is a pretty neat device. Definitely go check them out. We should get another bag coming in here momentarily. Well, it's now Saturday and I haven't checked the mail in the last couple days, but my email said that I had 2 packages come in. So when I just came back from the box after a little evening run this afternoon, I noticed there was actually 3 packages there, which is actually great because that's the last 3 packages. So I must have got one today. One of them didn't have tracking on it, so that was the last one. However, last night I came home late, not just after work, but from a job that I did for a friend of mine, who actually I filmed that job too, so that project will be coming up soon for you to view. But anyway, this particular box was on my desk, and you can see this was from Robert M. Now, Robert M. comes from Haddonfield, New Jersey, and that's the guy I actually did the 2 power supply conversions for. So I was kind of curious. I said, huh, what's this? I had no idea something was coming from him. And it was a tray of cookies, and that was awesome. Now, I didn't open the tray of cookies yet, because underneath the tray of cookies was a box of chocolates. And I'll give this place a plug because these things were delicious. And you can see, yeah, my wife and I have already bitten through several of those already, but they were very good. So that was a sweet treat to come home to. So thanks, Bob. So we'll go with Thursday's package first. You can see it just says electronic parts. Again, this was one of the guys that came from China. Nothing interesting on the other side here. Now, I have not opened any of these 3 yet. I wanted to wait to do this before the camera. Now, of course, I know what this is. We'll leave it a surprise. Okay, the first item up is a project box. Now, I wanted to see what kind of quality these boxes were in because they were very cheap. I can't even really get it open right now. Let's see. Oh, there we go. Yeah, not bad. It's got standoffs inside. It's got a lid. Really, what more can you say about it? It does curiously have a couple cutouts in the side over here. I'm not sure what those are even for, but it does have them. And the lid has a cutout on one side, although they don't really coincide with the cutouts. Now I'll just really quickly pull up behind me the details on this. And we're going to see this came from seller Alice 110-1983 on eBay. And this particular item cost me 99 cents. Now, since this all came from one seller, there were shipping charges per item, and they gave me a total shipping cost of $5.55 minus a $3.05 credit. So you do the math on that there, but that's a 99-cent project box. Usually those things sell for a couple bucks, but there is definitely a step down in quality. Okay, the next thing here, this is a charge doctor, and this thing is hopefully nicer than the one I already own. Now you can see it does have 2 outputs, which is kind of nice. You can actually monitor 2 separate devices. There's nothing on this end over here. It's in kind of a smoked case. But you notice this one actually has volts and amps listed together. And I'll actually just pop one I have here in the background off. This is from a standard charger doctor. And this has just got a standard USB in and out. But you can see the problem with this one is it doesn't have this lead. So when you plug this into something, you have to only plug it in a certain way. So if you have an outlet that sits in a different direction, you might not be able to read it, or you know, maybe this sits the other way, which of course that wouldn't work. So this guy here, we can plug in any direction like this, and we could read it a lot easier. And I kind of got this for the camera. This one I got for just testing purposes because I've seen it in other videos. I thought it was pretty cool, and it was a cheap item. But once I started using it, I figured, you know, it's much better to have a lead on it. I've seen this exact same one with this same kind of plug on the end of it too, but I decided to go this way. So what I'll do now is I'll plug that in, and we'll pitch the camera up here where I have a plug, and we'll test it out and see. Yeah, now that's nice, and I like that it's two different colors. You could have got it in all red, but I went with red and blue just so it stands out. And it's just yet another LED thing to have lit up on my desk here. But this is going to be useful for diagnosing certain things. Like, for example, I could plug it into this hard drive over here, and we can see how many amps it's drawing. And the second one isn't lighting up because there's only one input, but if I put a second one on top here, it should switch back and forth between the two different outputs, which is pretty cool. So that's pretty nice. That's a definite nice thing to have. And that thing was cheap. That was $4.57. And the last thing to come out of the bag, this is actually exciting. This is going to be a really big project to build. And at the end, I'm going to give this to a really good friend of mine. I mentioned I did a project late last night, and it was actually for him. So I won't delve into any more. There's definitely going to be a video on that in the future, as there will be on this one, but he has no idea. I just asked him what color he wanted. He has no idea what this is going to be. He's seen smaller versions of this. Well, right away I like this because it has a little plastic case to organize everything. But this is an 8 by 8 by 8 LED cube. And there's an entire bag of LEDs here. And it's a lot. 256, if I remember correctly. Oh no, I'm sorry. 8 times 8 times 8 is 512. Yeah, so there's 512 LEDs in here. And at some point, we're going to manipulate every one of those. Now, if you don't know what one of these cubes is, this is a 3 by 3 by 3 version. So you can see it's 3 by 3 by 3. This is going to be 8 by 8 by 8. So you can imagine it's going to be a lot larger of a sphere. Now this is powered by an Arduino, and I'll explain more how this works in the actual build. But when you see like a strip of LEDs on, like any particular row, it's actually not all lit up at once. There's actually some magic going on here where, like right now, watch it, they're all going to blink. But they're not actually all blinking exactly at the same time. It's actually blinking one, then the next, and then the next, so on and so forth, so quickly to the eye, it looks like they're all coming on at the same time, but they're really not. That technique's kind of, it's called multiplexing, basically. And the Arduino is basically sending out signals on every one of those pins to be able to multiplex this. I'm probably not explaining that the best, but there's kind of a limit to how many of these little LEDs you can hook up with just the one Arduino chip. This board, as you're going to see in a minute here, has a lot more chips to it. There's a huge controller here, and the outputs of these are basically going to go to all these, I think they're shift registers, and that's what's going to assign to every single column. That's basically what you're doing here. These are pixels. Think of it like that. Every one of these LEDs is assignable by row and by column. So column A, row 1, column 2, row 1. You get the idea. But to build this, it's going to be a fun task, especially manipulating this. At this level, it was fun because I had to make like sub assemblies. Each LED had to get manipulated in a certain way. If you see up close here, the wiring was bent and twisted in a certain way so that the leg below it would interact with it. And then at the grand scheme of things, once you got one, you had to do all of them, and then you had to solder them together in rows, and then put the rows together into columns, and then you put the 3 columns on top. It was a whole big thing, but 512 of those is going to be a really fun build. And I mean that. I do find these kind of things challenging. This is definitely going to be the most challenging kit build I've ever done like this. We'll have a look at the components. And yeah, there's IC chips in here, which is nice, so we can solder those chips in, the actual sockets first, and then we can put the chips in on top of it. And I won't go through everything that's in here in this particular video, but there's standoffs in here for the corners of the boards, little bits of wire, everything we're going to need. I'm sure they're not the most expensive components, but you know, for the price of the kit, which was an amazing hang on, I got my calculator in the way, which was an amazing $17.17, which is kind of mind-blowing. You're paying very basic bare bones for the parts, of course. And by the way, I'll mention, if you look, these are just your standard like indicator style LEDs. They're not like the super bright crystal clear ones like you normally see, but you want that because you want the light to be diffused, and that's what you get with these. If you look and see, they're the cheapy kind of LEDs. They're not the super bright ones. I mean, don't get me wrong, this thing's gonna be plenty bright as it is, but you get the cheaper ones with this kit for a reason. But these things assembled, I see them go for a few $100s, so definitely a valuable piece of kit here. And package number 2 says it's just individual LEDs, so we'll go ahead and slice that open. And this should be some straw hat LEDs, hopefully. And I think I ordered 100 of them. Let's see if that tells us anything. Not really. Let's see. These do indeed look like they're straw hat LEDs. Hopefully I picked out the right ones. Yeah, that's what they are. See, straw hats are really short. They don't have a lot of epoxy on the top of them like a normal 5mm LED would. So the light emitting unit, basically the little part in there, is right up at the very end. And it does have a different kind of light than normal LED. I'm going to have a video on these separately. I'll actually show this lit up though, because I have to move the camera to get to my regular LEDs. But you can see it's kind of a very focused point of light. And what I'm going to do, as I mentioned this earlier in another video, is I'm going to take this LED lantern, which is something I got from my wife for Christmas, and I did do a review on this. But this has white straw hat LEDs in it. And I have plenty of white lanterns, but I don't have any red lanterns, and I really want one for different reasons. Mainly, when I go camping, I go by myself a lot, and you know, the light's more of like a convenient thing, honestly. When I have the campfire going and my eyes get adjusted to it, I have plenty of light for myself. But what happens is when you turn on a bright light, you lose that night vision. But red lights, you don't. And if you're doing something up close real quick, not such a big deal. So I have a hat light with red and white. You know, plenty of white lanterns, but no red lanterns. So I figured this is how I want to do it. Plus, most of the time, if you do have one that's multicolor, white goes on first, not red. So I want something that's just going to be a red lantern. So I figured I'm going to just desolder all those LEDs and solder these in there. And we'll see what happens. We'll see if it's actually going to be, you know, a viable thing or not. Now, if you look in the white ones here, you can see there's that yellow phosphor kind of material, and that's what actually glows when the LED is powered, essentially. And you'll notice that the red one here, it doesn't really have that because it's a different chemistry. And also you'll notice it's not as wide, but these are purposely wide because you're trying to get as much light output as possible. So we'll take a look at that future build. And by the way, this is definitely a pack of 100, and it's $7.82, including the shipping, which isn't a super duper steal, but that's not that bad. Usually, you know, the regular LEDs are a little cheaper, but the straw hat ones, I guess, could be a little bit more money. But at either rate, this should be a pretty cool build later. And finally, the last bag. This just says side printed circuit X3, and you know, this is, I'm sure, going to be the least interesting out of everything here. But again, as I mentioned in part A of the video, and maybe at the beginning of this video, a lot of this is just parts for various reasons. Now these are all just Veroboard. I had other ones but I was using before from Shore Electronics. I had boatloads of them, but I wanted something a little bigger, so I went with these guys this time. And there's no traces on this, they're just individual points, and they're two-sided, so you can make your own traces on this. There's also these handy pads at the end for connecting wires to, I'm assuming. And they're also indexed. You can see there's numbers and letters going along the sides and top over here. And they came in packs. I believe there's 5 per pack. Yep, that's what it looks like. And I did get 3 packs. And I'll pull up the details of this in just a moment. And I also got a bunch of these USB ports. Now, fans of my channel and me know that I like my power supply stuff, and I keep alluding to future power supply builds. Now these are going to be used for that. I anticipate building little circuits. Now hopefully the spacing is right on this. I'm not necessarily worried about the snaps, but the spacing does look like it's right on. Maybe a little off, but we can always finagle that a little bit. But this is going to allow me to build like USB charging stations, or perhaps put more outputs into my little benchtop power supplies, things like that. In fact, a little quick idea comes to mind is using one of these and one of the green, the actual green LED voltmeters that I had actually in part A of this video series. And you could probably make up like a quick little test board, very similar to my charge doctor over here. And I want to thank you for watching this video. If you're not already a subscriber, you can click the link up here in the corner to subscribe to my channel. You can also check out these 2 links over here to these videos if you want to see some more of my stuff. Don't forget to give this video either a thumbs up or a thumbs down, and we'll see you next video.